Hey, what's up, guys? Oh no, chat's not working again. That's super annoying. Let me see if I can figure this out. This is dumb. Let me see. How's everyone doing? Today we will be doing the control flow structures. So we're going to learn about case, conditional, and the if statement. So that will be a lot of fun. And sorry, I'm a little distracted right now because I'm going to try to figure out why chat's not working. I think last time it was YouTube's fault, so I hope that's not the problem. And sorry if you hear my dog breathing in the background. We just played frisbee, so now he's extra loud. All right, chat overlay. Okay, well, hopefully it works for us. Otherwise, we're out of luck. Yeah, Sasha, I have Livebook installed and I've used it and it's really nice. I just need to like use it like a real tool. And then I think I'll appreciate it a lot more. But awesome. Thanks for being here, guys. I'm excited to do another live stream. And tomorrow, unfortunately, sorry, my mind is blanking. One second. Zach Daniels from the Ash Framework, the creator of the Ash Framework, he had to cancel last minute for some personal stuff. So unfortunately, I don't have a guest tomorrow, but we rescheduled him for June 7th, I believe. And so I'm going to do another Elixir Getting Started guide tomorrow as well, but we'll do it at 1:30 in the afternoon instead of 10 a.m. So it's a bummer, but you know, it happens. Life happens, right? I guess I'm going to disable the chat window because it's not working, and that's sad, but it is what it is. I'll try to just read all the chats that are relevant that I can respond to. But let's go ahead. Let's jump in. I'm going to open up Firefox. And we will go to elixir-lang.org. And I have to switch my view. There we go. And we're going to click on the guides up here. And today we are focusing on the case, conditional, and if control flow structures. So this is going to be a good one. These are very useful things to use in your code. So let's go ahead and just jump in. So in this chapter, we will learn about case, conditional, and if control flow structures. So case allows us to compare a value against many patterns until we find a matching one. So in this example, you'll see we have a case statement with a map that we're comparing to, but the map has set arguments. So we have 1, 2, and 3. So it would actually have to match that to match, right? So if you go down, we match 1 and 3, and since we have an extra variable or a variable here, it will match this. So as long as we set the variable x to 2, right? And then if we don't do that, it'll fall through to the default conditional statement, which is usually just an underscore. And so this will be the default return value if no case is matched. So let's go ahead and try this. I'm going to open up my terminal. Oh no, where do I have it? Whenever I have it on new Windows, I have to play the game of find my terminal, because for whatever reason, in one of the later Mac updates, I feel like it doesn't pull it open. Usually, like when you switch, it would just like open up that desktop, but it doesn't do that for me anymore. All right, so terminal is up, and let's go ahead and start our Elixir shell with IEX. Cool, and then we will we're going to go through this case example just to show you how it works. So if we do case here, and we're going to match against a map with 1, 2, and 3, and then we can go into our case statement, and if we don't have an end to this, it becomes a multi-line in the Elixir shell. So if you didn't know that, that's how this works, which is really cool. So we can go ahead and just continue on the next lines. And so our first statement, we're going to match if our map were 5, 4, 5, and 6, this condition would be matched. And we'll just have a string here that says this clause won't match. All right. And then we'll have another condition down here where we take 1, a variable x, and 3. And so as long as variable x equals 2, this statement will match. So this clause will match and bind x to 2 in this clause. Okay, and then we're going to have our default case, whoops, and this clause would match any value. All right, cool. So now we have to just end this case block, and variable x is unused. All right, so what we can do here is, I should have set this to a variable so I could call it easier. So anyways, if we were to go like this, x equals 2, we would have gotten this statement. And I believe we actually have to use the pin operator if we want to match a variable that is outside of the case statement. So if we did something like this, so x equals 2, and let's see, if we do case, let's see, case, we'll just copy their example, 10 do, and then if we want to use the pin operator, x, and this won't match because x is equal to 2, not 10. And then if we do our fall through, it will match down here. And then we'll end that. And so we got our default value will match. And then if we were to do the same thing, but we do case 2, and then we pin to our x variable, which is equal to 2, now this will match. So we can do that. And then our default won't match. Okay, and then end, and then there you go. You see that since our x variable matches the case, that matches. So like I just said, if you want to pattern match against an existing variable, you need to use the pin operator. So that's important to remember, especially if your variable's outside of the case block. All right. And clauses are also extra conditions to be specified via guards. So we haven't really learned about guards, I don't think. And where are guards in the Getting Started guide? Well, we'll talk about them a little bit. So a guard, when you see this when argument or function here, that is a guard. So in this case, we're actually checking to make sure x is above 0. And if it is above 0 and would be equal to 2, then it will match. If the condition is not satisfied by the guard, then it would not match. So honestly, I think what we should do here, we should set our variable. Well, we can set our variable equal to 2. But our case statement, we could have just a parameter that we don't care about. So anything coming through would technically match, but then we're going to make sure that it is above 0 and it will match. So let's go ahead and jump over to our terminal again. I'm going to clear this so we can see. So if we go ahead and create a case block and we do 1, and I'm going to do just an underscore because we don't care about this one. And oh wait, but first let's make sure x is still equal to 2. Okay, it is. So all right, if we do 1, we're not going to care about the middle value here. 3, and it's a case statement, so I need to have case in front of it. And then we need to do open up our do block here. And now inside of this, if we have our first case where 1, and then we need to pin to check against x, and 3. And then if we throw in our guard, so when x is greater than 0, then this condition will happen. And this condition, it will match. And if it doesn't match, we're just going to have our default return there. And it would match if, let's see, if guard wasn't satisfied, and then we can end that. I honestly don't know. Whoops. I need to put an end here. I'm not sure if we need, oh, I can't do that. Can only be used inside patterns. Oh, I see. I should have done that. Okay, we're going to do this again. So we're going to do case. We're going to pass in our map to 3. And I need to ignore the middle pattern in our case. So we're going to do 1, and then we'll do an underscore x here because we don't care about that value. And we're going to do 3. So I'm just going to do that underscore, and then we're going to have our when, and I'm going to pin to x. I believe I have to pin is greater than 0. Then this condition will happen. And we'll say will match. And if it doesn't match, we'll say will show if guard isn't satisfied. And oh my gosh. Okay, so I guess we can't pin it. Bear with me, guys. I feel bad because now I am rewriting this for the millionth time. All right, let's try this again, guys. I will get this, I promise. 1, 2, 3. This is the problem when I try to do examples on the fly without running through things first. So we're going to, if the case with 1, we don't care about the middle value, and 3 is matched as long as x is greater than 0, then we are going to say it will match because x is 2. And then our default, our default case won't show. And then end. All right, guys, maybe third time's a charm. Boom. All right. So there we go. We can't pin the variable when it's in the guard, but if it were in our condition we're checking, you have to pin it. And that is something I feel like the compiler would yell at you if we weren't in the IX shell. And that is the benefit of, using a language server to yell at you when you're doing naughty things. So that's pretty cool. And so it passed our guard statement, or our guard condition, which is cool. So we had multiple conditions that it had to pass through to hit that condition. So Keep in mind, errors in guards do not leak, but simply make the guard fail. All right, so if we say head of 1, we get an argument error. So case 1, x1 won't match, got 1. Okay, I'm not 100% sure. So if we try to get the head of not a list, we get an error. That makes sense. All right, and let's see if we got 1. Okay, so we're going to set x to 1, and then we're going to pass it into this case statement, and it will tell us the value. So keep in mind, errors in guards do not leak, but simply make the guard fail. Okay. Oh, okay. So what they're demonstrating here is we're passing in one value, and we're not going to get this argument error here. This condition is just going to fail, and we're going to get this value back. All right, that's cool. So let's go ahead and try this example out. So we just saw if we try to pass a non-list into the head function, we get an error. So now if we create our case statement where we're checking against our case equaling 1, and we say x when hdx, this won't match. And then we're going to say x, so as long as x matches 1, it will fall through. Let's see. And then we're going to just interpolate the value and then end. And I think this is going to fail because x is equal to 2. Oh no, it went through. Okay, cool. So the error didn't come through, which is good. So so the guard just fails. It doesn't give us our argument error, which is good to know, which is cool, I think. And then when it matches a condition, it went ahead and spit that out. If none of these clauses match, an error is raised. So if we create a case statement that we're looking for the atom OK, and we only have an error case, won't match. Obviously, it doesn't have a case, so we get a case clause error. So no case clause matching OK. And the Elixir language server will yell at you if you do this. It even warns you if you have cases that are never being met. So those are good things to be aware of. All right, so let's see. The documentation for the kernel module lists all available guards in its sidebar. You can also consult the complete patterns and guard reference for in-depth documentation. Patterns and guards. I feel like after the getting started guide, we'll go, oh, here we go. Patterns and guards. So we'll do this after the getting started guide. I guess we'll just go in order since it is a reference, because going through patterns and guards, I think would be incredibly beneficial. All right. So now that we learned about case statements a little bit, we can go on to conditionals. So case is useful when you need to match against different values. However, in many circumstances, we want to check different conditions and find the first one that does not evaluate to nil or false. In such cases, one may use conditional. So 2 plus 2 equals 5. That's not true. 2 times 2 equals 3 is not true, but 1 plus 1 equals 2. So this is true. So with a conditional, it's just the first condition that is met that is true will come through. So let's go ahead and test this out. I'm going to clear this so we can see the top easier. And so conditional you're not checking against a pattern at the top anymore. So we're just doing condition do, and then you check against the conditions on each line for being true. So if we do 2 plus 2 is equal to 5, this is not true and it will not show. And then if we do 2 times 2, also, I'm sorry if you guys can hear that. Hopefully my mic is blocking it, but there's a weed whacker going outside of my door. And this obviously is not equal to 3. So this, we'll say nor this, just like the documentation. And if we do 1 plus 1 equals 2, this is true. This is true. So then if we end this, we're going to get our message, this is true. So the conditional went down the line until it found a true statement. So with this, if a true statement, you could have multiple true statements, right? But the first one that gets hit, it goes through in order, it will stop there. So if this one was true, it wouldn't also be true and show us both outputs here. All right, so this is equivalent to else if clauses in many imperative languages, although used less frequently in Elixir. So yeah, that's true. So this, you could use if and else if to do this, but you can also use else if in Elixir. And I believe they don't have any else ifs, but anyways, we can do it in Elixir as well. Let's see. So if all the conditions return nil or false, we get a condition clause error, just like we saw with the case statement. So let's see. If we make all of these, let's see. If all of the conditions return nil or false, you get a condition clause error. For this reason, it may be necessary to add a final condition. So just like we added the underscore, so we had the fall through in the case statement. If you use a conditional, you have to say true there because it's looking for truthy and falsy evaluations. So you have to have true. So that would be our default fall through here. So if this was false, our default condition, you have to have true, and that's our default fall through. So let's go ahead and run that example. So if we do condition do, and we just do 2 plus 2 equals 5, this is not true. And then if we do 2 times 2 equals 3, same. And then we have to have our true statement, and we'll say default condition. And when we end that, so there we go. None of them are true until we hit the end there. And so it's pretty common practice to always end your conditionals with a true at the end. All right, so finally, note conditional considers any value besides nil and false to be true. All right, so that's good to know. So if we took the head of a list, that's value 1. So 1 is considered true, and you'll get this response out of it. Let's go ahead and try that out. Condition do. And we want the head of our list. That is 1, 2, and 3. And, whoops. All right. And then we'll say 1 is equal to true. And what did I do? Oh, I forgot to close my head function. Sorry, guys. Typing is hard sometimes. All right, now if we hit end, there we go. So 1 is equal to true. So any value, as long as it's not nil or false, will be true. Okay, now we're moving on into the if unless. So besides case and conditional, Elixir also provides the if function arity of 2 and the unless function arity of 2, which are useful when you need to check for only one condition. So yeah, it's not as common to do like if else and then else if blocks. So if you're doing multiple checks, obviously you can do an if else statement, but if you're doing more than 2 conditions, you're not going to stack. Oh, good. I'm glad my mic is blocking it. I just found an awesome YouTube video. This is a beacon mic, and I forget who it is, but I just found an awesome video where he set up everything. And so I set it up. You hear me breathe a lot less too, I think. So that's good, because that really annoyed me when I edited my videos, but it was too hard to like edit out all my breaths. But yeah. So you're not going to really see like else if blocks where you have, if you're doing more than like 2 comparisons in Elixir, you would go more towards like a case or conditional statement. And so now we'll go ahead and go through a little if statement, unless statements, and unlesses are very confusing. I don't use them very often. I don't think I ever use them because it makes it, my brain just doesn't want to work that way. Because so like if you do this, let's just pull up our terminal again. I'm going to clear this. So an if statement. So as long as this is true, whatever condition you have here, so we're going to just do true for now. It will spit out whatever you're doing here. So this works. And okay, so that condition is true. And then, so unless is when we do unless. So if we do unless true, this is false. So it's never going to show because unless is flipping the Boolean around. So this isn't true. So we get nil out of it. For unless to work, we'd have to do false here. And that is actually, this is actually true. So it's just the opposite. And I rarely do these because, like I said, it confuses my brain. And maybe, I don't know, maybe I'm weird, who knows. But I usually like to avoid using unless, and I'll usually use ifs. And instead of like, if I want the opposite, you use like not equal to, or something that makes a little more sense to your brain than the unless. But maybe I'm an outlier. I don't know, but it hurts my brain. All right. So as we move down, so if the condition given to if arity of 2 returns false or nil, the body between do and end is not executed, and instead it returns nil. So as you saw, when we did the unless true, it returned nil because this isn't evaluated and is not executed. And the opposite happens with unless. Yep, we just talked about that. So they both also support else blocks. So we can do if nil, this would never happen. And then the else block, this will happen. And then this kind of guarantees that if this doesn't evaluate to true, you always you're controlling what happens instead of just getting nil back. So you can then evaluate, a different function here or handle your condition or data differently, however you need to, right? So let's go ahead and try that out. So if we say if nil, that means this will never happen. Else, this will happen, because it's the fall through condition essentially. So there you go. So that's how that works. And we can also do an else block after unless. So if we weren't using, so if we did unless true, this won't happen. Else, this will happen. And so there you go. Same results. different function. All right, so this is also a good opportunity to talk about variable scoping in Elixir. If any variable is declared or changed inside an if case and similar constructs, the declaration and change will only be visible inside the construct. So for example, if we set a variable equal to 1 outside of an if block, and then we rebind it inside the true or the if block here, we're going to get 2 back because it's true, but it didn't rebind the variable outside of the if construct here. So if we check X, we still get 1 back. And I think this is a very important thing to keep in your mind, because you don't want to expect different results in your code base, right? So let's go ahead and play with that example. So if we say X equals 1, and then if we say if true, and inside this condition, we rebind X with adding 1 to it, and variable X is unused. Oh, and okay, so it's saying it's unused because we set it and then didn't use it inside the true condition. So that's why we're getting that warning. But now if we go off this example here and we check X, we see that it is still binded to the value 1. So in said cases, if you want to change the value, you must return the value from the if block. So if you actually wanted this variable to rebind the way that you would expect it to, we actually have to do this. We have to say X equals, and then say if true, do. And if we do the same thing here, X plus 1, so we're just returning the new variable. We're adding 1 to it. And then if it's not true, we could also have an else block here and just return X and then end. So when we do this, we're rebinding the variable that is within the same construct. So instead of being inside the if block in a new construct, it is at the global level, I guess you could say, or like at the module level. So now we get 2 back, same as before, but since we rebound the variable here, it will now be 2. So I think that's pretty cool. And a good little thing to know is if and unless are macros. In fact, like a lot of functions in the Elixir language are macros. So an interesting note regarding if arity 2 and unless arity 2 is that they are implemented as macros in the language. They aren't special language constructs as they would be in many other languages. You can check the documentation and their source for more information. So one cool thing, and not to give myself a little plug here, but in my Elixir, A Comprehensive Introduction, it's a course that I'm selling. I'm actually just wrapping up a metaprogramming basics section, and we create our own domain-specific language and learn how to build our own macros, which is really, really cool. And I go through this stuff and I show you how you can see the abstract syntax trees and everything, like how you can actually dive into a macro and see how they work. So that's really cool. Not to plug myself, but if you're interested in a deep dive, that is in my course, which is currently for sale, and you can find it at elixirmentor.com. And so that will have concluded the introduction to the most fundamental control flow constructs in Elixir. Now, let's learn where code and data meet anonymous functions. And so we're going to be diving into anonymous functions tomorrow, since I'm not doing a guest live stream. So that'll be cool. So we're doing one more of those. And yeah, this was a lot of fun. And also I apologize for all the retyping at the beginning of this when we went through this case statement. It was a rough start for me. the pressure of being live. Guys, I appreciate you. Thank you so much for tuning in. And I'm sorry the chat didn't work today, but I blame YouTube. But anyways, this was a lot of fun, and I'll see you guys tomorrow.
Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.